What's poppin', dogs? It's Mr. Allen, and we're about to determine if the following sequences, and here we got functions, are either linear or exponential. All right, so linear, we're going to have a constant rate of change, the same rate of change, either going up by the same number or down by the same number throughout the entire sequence or this table that we have here. Now, if it's exponential, we're looking for things like it's doubling, okay, or the rate of change is doubling, or it could be being cut in half or being cut in thirds, right? Same goes, it could be tripling, quadrupling, whatever, okay? So first one here, let's see. To go from 2 to 5, I add 3. To go from 5 to 8, I add 3. 8 to 11, I add 3. So this one's looking like it is linear. It has a constant rate of change. They may even ask for like the common difference. Our common difference, or D here, would equal 3. Okay, cool. Next one here. I got negative 16, then negative 8. So it goes down by 8. Or so it goes up by 8. Yep, there we go. Negatives. And then it goes up by 4. And then it goes up by 2. Interesting. The rate at which it's going up by is actually getting cut in half. That is indicative of exponential. In this case, it would be exponential decay. Okay. Now, I know we didn't ask if it's growth or decay, but why not talk about it right now? The rate at which it's increasing is decreasing, right? So it's going up by 8, then by 4, so it's getting cut in half each time. Negative 16 divided by 2 is negative 8. Divided by 2 is negative 4. Divided by 2 is negative 2. So we may even want to say that we're multiplying by 1/2 here, times 1/2, times 1/2, times 1/2. So my common ratio here would be 1/2. They may ask you for that common ratio after determining if it's linear or exponential, or they might say, give me the common difference if it's linear, give me the common ratio if it's exponential. So there we go on that one. Next one here. These are interesting numbers. We've got 6 to 7, that's plus 1. Then it's plus 2. Then it's plus 4. Ooh, the rate at which I'm going up is doubling. So in other words, we're multiplying by 2 to get from 1 to the next, right? So now we're not multiplying the 6 by 2, but the rate at which it's going up there, our common ratio for this one would be positive 2, okay? We could actually write an exponential function for this. We're not going to do that here. This one is a growth one, so exponential growth. Definitely a little bit trickier to see because we don't actually have the numbers in the sequence that are getting doubled. It's just the change from one to the next is doubling this. You might not be at that one yet in Algebra 1. Maybe they'll throw that one at you, but these are probably a little more your speed right now if this is an Algebra 1 situation. All right, next one. We got our tables here. So from here to here, from 1 to 3, we're going up by 2, or we're tripling. From here, from 3 to 9, that's going up by 6, so that's not constant. So let's say this. We're multiplying by 3. Multiplying by 3. 9 times 3 is 27. Times 3 is 81. So this is going to be an exponential growth. So exponential growth here. With our common ratio being positive 3. Nice. Cool. Next one here, we got our x's constantly going up by 1. That is also, another important thing here, that we're going up by 1 each time with our x's. We want that to be constant to really make just a comparison for our output values. So we're going up by 1 each time. Here I'm going down by 4, down by 4, down by 4, down by 4. So we're subtracting 4 each time on this one. Those are 2 very different 4s, 3 very different 4s. All right, so this is linear, and our common difference here is negative 4. And our last one here, h of x, we subtract 5, but then 2.5, then what? Hold up. Are we just getting cut in half? Yes, we are. We're multiplying by 1/2 here, times 1/2, times 1/2, times 1/2. So this one is exponential decay. Perhaps you've learned growth and decay. You should have known that right off the bat. I think usually they'll start with, is it growth or is it decay? So this is exponential decay because I'm cutting it in half each time, and that common ratio will be 1/2. All right. Excellent. For this one, all they asked for was it linear or exponential. I just added some bonus stuff in there because I know those are questions that could be asked on a test or a quiz, and, got to get all them points, you know what I'm saying? All right, there we go. That's it for determining linear or exponential on this one. So thanks you guys for watching, and stick around, keep on watching, because this is just going to go get exponentially more fun. Get it?